So here we're going to be talking about scatter plots. And a scatter plot is basically just a set of data that's represented by a relation on a coordinate plane. I'm just going to call it a graph here. And what that really means, a set of data is really just a list of numbers. It's just a set of numbers. But the relation is the important part here. A relation always represents a set of x and y pairs. So the data in this case actually represents two variables. So a scatter plot is really just a set of ordered pairs on a graph. The correlation is the trend of the data, the trend, or the relationship between the two variables. So for right now, we're going to talk about those as positive, negative, constant, or no correlation at all. I'm just going to say none. And that pretty much directly relates to slope. The only difference is that slope is talking about a line where every single point follows the exact same rise and run, whereas correlation just follows a general trend. All of the points generally float positive or generally go negative. Constant kind of connects to a slope of 0 where they generally go straight across. None means there's no connection at all. That's just a scattering of points. So a positive correlation means that one variable increases, and so does the other one. As one variable increases, the other also increases. So if we're talking about in a race, your time and your distance should both increase. Let's say we have our x-axis as time, our y as distance. As time passes in the race, you're going further. As your time increases here, your distance also increases. That has a positive correlation. They're generally trending up. It has a positive slope. Actually, that line that I drew is called a line of best fit. So the points you can see, they're kind of scattered. They don't all get hit by that line. Actually, I'll draw other ones in there just to stress that. They're not all hit by that line. Well, sorry, actually, this point doesn't make sense. That means you went backwards in the race. They're not all hit by the line, but they generally trend with that line. Actually, that's all a line of best fit does. It generally floats in the middle of your scatter plot. No correlation means that two variables do not affect each other. So your hours of sleep per night and the number of times you've been outside of the country, your sleep versus your visits to faraway lands, those have no connection. They just aren't related variables, so I'm going to just make up some points here. Hopefully you're not getting 2 hours of sleep per night. But you can see that there's no general trend. They're not generally going up. They're not generally going down. There is no association between these two variables. The last one here is a negative correlation, which means as one variable increases, the other decreases. So the hours of video games and the hours of homework that you complete. Let's put homework down here and video games here. Those actually have to be negatively correlated. If you spend more time on homework, let's say you spend 8 hours on homework, you have less time to actually spend on video games. Let's say you use 2 hours for video games. Let's say the exact opposite is true. 2 hours for homework, 8 hours for video games. But you know that that time is going to be scattered, but generally trend down. This person's spending 6 hours on homework, 7 hours on video games, most likely not spending any other time on anything. This person's not doing a whole bunch of either. Or let's say this person's really not doing a whole bunch of either, but generally that does have a negative correlation. The line of best fit has a negative slope. It does not connect all the dots. It just generally follows the trend of each of these collection of points. So one of the biggest values of a scatter plot is that you can make predictions off of information that you have for information that you don't. So this describes the oil changes versus the engine repairs. So if you get more oil changes, you have to spend less money on engine repairs. You're taking better care of your car. So this person, this is one piece of data that's saying that they did 10 oil changes per year and they never had to repair their engine. This person did not change their oil at all. They had to spend $600. Now, it's not always true that you're going to have to spend more money with less repairs. With less oil changes. This person had one oil change, and they spent a little bit more money than them. But the general trend is that you spend less money if you change your oil more often. So, how many oil changes per year would a person have if they spent $300 on engine repairs? So we're thinking about using this line of best fit, not the data. We're using the line to try to make this prediction. What would you expect if they spent $300 on engine repairs? I would expect that it's going to follow that line, and they would actually, this one piece of data lines up perfectly with it. They would have 5 oil changes. If a person had 7 oil changes in a year, how much would they pay in engine repairs? So 7 oil changes per year. We happen to have another piece of data that lines up pretty well with that, but I really want to use the line of best fit, not individual pieces of data here. This looks like they're spending, let's say that's halfway in between that 100 and 200. I'm going to say they're spending about $150 on engine repairs. All right, so this graph is actually just the scatter plot without a line of best fit. So the first thing I really want to do, I just want to sketch a line of best fit, and it doesn't have to be perfect. There is a way to get a perfect line of best fit, but without a graphing calculator, it's very difficult to do. So I'm just going to sketch it, and it just generally has to go between these points. All right, so it's going through the middle trend of that data. You see what we generally have about the equal number of points on either side of that line. And we're going to use that to make these predictions. How many calories are in a sandwich that contains 17 grams of fat? So I'm going to look at 17 grams of fat. That's about there, and follow that up to my line. I do not want to use this point. That's one piece of data that's not really relevant to the whole trend. It might have happened that one time, but it's not generally what I'm expecting. 17, I'm going to follow that up. That looks like that's sitting at about 450 calories. How many grams of fat are in a sandwich that has 600 calories? So I'm going to change the color just so this doesn't get so messy. 600 calories, and then I'm going to follow that across again. I'm not looking at that point. I'm looking at this point on my line of best fit. That looks like about, let's say that's 32 grams of fat. Oops. And the last one, estimate how many calories the sandwich would have with 20 grams of fat. So I'm going to follow this x-axis over to 20 and then follow that up to my line of best fit. I'm going to say that's directly in between 450, maybe a little bit higher, 450 and 500. Directly in between would be 475, so I'm going to say it's a little bit higher. I'm going to call that 480. All right, this graph is talking about the average temperature and your monthly heating bill. So as the temperature goes down, you spend less on your heating bill. Sorry, excuse me, I said that backwards. As this goes up, you spend less money on your heating bill. As this goes up from 0 to 100, which should make sense, the temperature is going up, you're spending less money on actually heating your home or apartment. So I'm actually going to draw a line of best fit just so I can make these predictions easily. That's actually a little bit higher than, or sorry, a little bit lower than I wanted it to be. Still not perfect, but it should be good enough for this. Shade in the answer that best describes a monthly heating bill in dollars at 0 degrees Fahrenheit. So if the temperature, the average temperature is 0 degrees, you're going to be spending a lot of money to heat your house. So that roughly is about there. Again, I actually wanted that to be a little bit higher, which would represent that answer. 180 is a little bit low. 5 is way too low. 0 is way too low also. You're spending a top amount on your heating bill if your average temperature is 0 degrees. If the 4 data points listed below are added to this scatterplot, they're added to that scatterplot, which point is an outlier? An outlier is just a point that doesn't fit in with the rest of the data. It stands out. So I'm going to actually plot each of these on our graph. 9 and 177, 9 and 177. That seems to blend in pretty well with that general pack of data up there. 25 and 60, 25 and 60. That one seems to stand out. Let's keep plotting the rest of them. This one seemed like that was okay. This one I have a question about. That doesn't seem like that fits in. 55 and 100, 55 and 100, that fits right in with those points. And 80 and 40, that also seems to fit that general trend there, so it is that one that seems to stand out. We're going to do one more where we have to actually create the scatter plot. So I'm going to plot these 5 points on my graph first. Alright, so I plotted my 5 points, and we can see that we're talking about the hours studied versus the actual exam grade. So the test score goes up generally as you study more. And that's actually what this first question is talking about. What's the relationship between the number of hours studied and exam grades? That is a positive relationship. That generally trends upwards. If a student receives a 90 on the exam, about how many hours were spent studying? How many hours would you expect them to study? 90, I'm going to follow that straight across. I would say, actually, these numbers kind of get off their lines. That's at 4, that's 6. Sorry, that's 2, 4, 6. So it kind of seems like this should be 7. This should be 8. This should be 9. This should be 10. That's 11. That's 12. Okay, so I'm thinking that's actually 8 hours. What grade should a student expect if they study for 7 hours? So I'm going to follow my 7 hours up to my line of best fit, and I'm going to say, well, if this is 80, this is 90, I'm going to say an 87. It's more than halfway in between that 80 and 90, so a little bit higher. I'm going to say they would get an 87% on that exam.